So we got this worksheet to build our intelligence on factoring, right? We're going to continue practicing so we could do a retake. And as you can see on this first section of this worksheet, I have quadratic trinomials and binomials, and these quadratics have an a value of 1. There is no number in front of any of these quadratic trinomials. They all have the a value of 1, a value of 1. So what I would like to do is go over a couple of these with you from each section and then give you guys the remainder of the period to work on these. So for example, let's jump to number 3 right here. And on number 3, because there is no number in front of x squared, because the a value is 1, you could jump right into this factored form format. So I hope everybody's following along. And why could I set this up with the x and the x? Because x times x is x squared. You would not be able to do that if you actually had a number out here. If you had a 6 out here, then it might be a 2 and a 3 or a 6 and a 1. You wouldn't be able to set up x times x because if you had a number, obviously x times x is not 6x squared or 8x squared. If you do have a number, we're going to do a different method, a multi-step method. But whenever you don't have a number, you set this up and you simply think what times what is your c value, 32, that if you combine together is your b value, negative 12. And I don't even think about b. All I do is think about c and make a list. And then once I have my list of multiplication problems that give me 32, then I could go back and start adding them and see which one gives me b, which in this case is negative 12. So how do I get positive 32? It could be a 1 times 32. It could be a 2 times 16. 3 doesn't work. It could be 4 times 8. 5 doesn't work. 6 doesn't work. 7 doesn't work. And then once you get back to 8, 8 times 4, you already have that right there with the 4 and the 8. So these are all the possible ways of multiplying numbers together to give you 32, besides changing signs. And then once you have your list, all you got to do is go back and add, and not multiply, but add 1 plus 32. 1 plus 32 is 33, and this number is not 33. If I add 16 plus 2, that's 18. This number is not 18. If I add 8 plus 4, that's 12. And this is a 12, but I want it to be a negative 12. And when I add 4 and 8, I get a positive 12. So I have the right number 12, but I just have the wrong sign, which means I have the right numbers, just the wrong signs. So you're going to change them both to a negative 4 and a negative 8. And that's the correct pair of numbers that you want. Now, what do you do with those numbers? You just put them in to the blank spots and you're done. A minus 4 right there and a minus 8 right there. Ta-da. Easy? Okay, so this is not the first type of factoring that we learned. I just figured I really want to hit quadratic trinomials that have an a value of 1 because it's so easy. You could set up x on every single one of these, thinking what times what is the last number, that if you combine together is the middle number, make a list to help you out, right? Now, what if I would have had, let's say a 10 right here. Yeah, instead of a negative 12, if I had a negative 10, well, then you'd be thinking like, well, that doesn't give me 10. This doesn't give me 10. If none of them give you 10, then you would say not factorable. Or you could also say prime. Yay? Okay. And that is going to happen a couple of times, maybe once, maybe twice on this whole worksheet where you just cannot factor it. You would say not factorable or prime. Anyway, let's try some more. How about this guy right here? Because there's no number in the front, you could set up parenthesis, 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 x, x, because x times x is x squared. That's the beauty of this section right here. Factoring quadratic trinomials when your a value is 1. And you simply think, what times what is the last number, c, that if you combine together is the middle value, b. I always make a list of the multiples of c. So how could I get negative 24? I want to start with 1 times negative 24. Then I'm going to go 2 times what? And if you don't know, you could always get a calculator and go 24 divided by 2, and that'll be a 12. In this case, negative 12. Okay. And then 24 divided by 3, that'll be an 8. Of course, we want a negative 8. 24 divided by 4 is 6. Of course, you want a negative 6. And those are all the possible ways of multiplying numbers together to give you that c value, negative 24. So the question is, which of these combined give me 11? If I add negative 24 plus 1, that'll be a negative 23. That's not a negative 23. If I add negative 12 plus 2, that'll give me a negative 10. That's not a negative 10. If I add negative 8 plus 3, that'll be a negative 5. That's not negative 5. If I add negative 6 plus 4, that's negative 2. That's not negative 2. So what does this tell us about this problem? Not factorable, right? Not factorable. So you'd say not factorable. What does that mean? That you are not able to factor. Well, I accidentally picked this one because there's only, I think, one of them, maybe two. Yeah, there's not that many, and this is one of the not factorable ones, okay? Let's see. How about number 4? Sure, let's do number 4. Okay, so once again, because there's no number in the front, we could set up parenthesis, 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 x. And we got to think what times what is a c value, in this case negative 32, that if you combine together is your b value, in this case negative 14. I always say make a list of your c value multiplication questions, right? So how could you get negative 32? 1 times negative 32. How about 2? 2 times negative 16. How about 3? 3 times, nope, doesn't work. How about 4? 4 times negative 8, right? How about 5? 5 doesn't work. 6 doesn't work. 7 doesn't work. Once you get to 8, 8 times 4, it's already represented. It's already represented right here, 4 times negative 8. Okay, so anyway, which pair of numbers combines together to give us the middle value, negative 14? Well, if you add 1 plus negative 32, that'll be a negative 31. That's not a negative 31. If I add positive 2, take away 16, right? If you add those, it'll give you negative 14, and that is what we want, exactly those numbers. You don't have to change any signs, exactly those numbers. So you're going to put a plus 2 right there and a minus 16 right there, and it's factored, right? Now, if you ever doubt that you have the right answer, you could always distribute, like, don't do this, but if you're doubting yourself, go ahead and distribute x times x, x squared. X times negative 16, negative 16x. Positive 2 times x, positive 2x. Positive 2 times negative 16, negative 32. And then combine the negative 16x with the positive 2x, and you will get the minus 14x that you have right here in the middle. So I've just verified that I factored it correctly, because when I distribute it and I combine like terms, I really end up with the x squared. I'll end up with the minus 14x in the middle and the minus 32 at the end. Again, this is just if you are doubting yourself, if you're like, man, I'm not sure if I got this right, go ahead and distribute it just to verify that you actually factored it correctly. This is a correct factorization. Anyway, you have a lot of practice on those. We also notice the last row down here, we have not quadratic trinomials, but we have quadratic binomials. But again, the a value is 1. So whenever you don't have a number out here, you might be able to set up parenthesis, give me one second, parenthesis, 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 xx. Why is that? Because x times x is x squared, right? How am I going to get 36, the multiples of 36? And you want to think, what times what is your c value, negative 36, that if you combine together is your b value, which there is no middle term, right? Technically, if I wanted to, I could rewrite this thing x squared plus 0x minus 36 if I wanted to. You don't have to. Obviously, there is no x term, there is no middle term. So when we're thinking what times what is our c value, negative 36, that combines together to give us the b value, which is 0, we're going to think of the list: 1 times negative 36, 2 times negative 18, 3 times negative 12, 4 times negative 9, 5 doesn't work, 6 times negative 6. And when you think about these numbers, when you combine them, negative 36 plus 1 is negative 35. There's no negative 35x in the middle, right? So you start combining them, and you'll recognize that 6 minus 6, when you combine those, that's 0. It cancels out, and there is no middle term. The middle term, the b value, is 0. So this is the pair of numbers that I want, that multiply together to give me the c value, negative 36, that combine together to give me the middle value, 0. So a positive 6 and a negative 6 is what we want right there. Positive 6, negative 6. Doesn't matter which one's positive, which one's negative, as long as the signs are different. Now, what if, again, the only time you could actually do this is when you have a minus sign between your two terms. Because if it were a plus sign, think about it, when you distribute, yeah, x times x is x squared. But at the very end of your distribution, you need 6, or a positive 6 times a negative 6 to give you a negative 36. That's the only way it's going to end up being a negative 36 with a positive and a negative. Not only that, that's the only way that the middle terms will cancel out. Let me show you. Again, x times x, x squared. X times negative 6 is negative 6x. Positive 6 times x is a positive 6x. And positive 6 times negative 6 is a negative 36. So as you can see, the middle terms are exact opposites. They will cancel out. If you would have had a positive and a positive, well, first of all, you're not going to get a positive 36 at the very end. That would mess it up. That would be a positive 36. Or if you had a negative and a negative, that wouldn't give you a negative 36 at the end. But not only that, the middle terms would not cancel out, because the only way these guys cancel out is because one's a negative 6 and one's a positive 6, giving you that negative 6x and positive 6x. So to make a long story short, if you have a plus sign right here, then you cannot factor it. It's not factorable. Yay? Okay. This next section says completely factor. What does that mean? That means to pull out the GCF and then continue to try to factor. That doesn't guarantee you that you're going to be able to continue factoring, but maybe you will. If we take a look at, let's say, number 20, okay? I'm hoping that I could pull out a multiple of 3, the GCF of 3 from all 3 terms. Does somebody have a calculator? Could somebody please go 72 divided by 3? That way I will be able to pull out a 3. Maybe I'm not. Let's see. Thank you so much. So we do end up with a 24. So let me pull out a 3 from each one. So if I pull out a 3 from my first term, 3 times what will get me back to the 3x squared? Well, that'll be a x squared. And then 3 times what gets me back to a negative 30x? Well, that'll be a negative 10x. And last but not least, 3 times what gets us back to a negative 72? And you guys just told me that it was 24. 3 times negative 24 will get me back to a negative 72. So we pulled out the GCF of 3, and you look at the inside of the parentheses, and you could continue factoring right there, okay? Just look at this blue quadratic trinomial that no longer has a number in front. Yeah, the 3's out. We pulled out that 3. There's no more number in front of the x squared. So because there's no number in front of the x squared, maybe you could continue factoring x and x right there, right? So again, on this blue quadratic trinomial, ignore the GCF of 3. I mean, we're just going to bring it down at the end anyway. But just focusing in on this blue one, I could start thinking what times what is my C value, negative 24, that if I combine together is my B value, negative 10. I'm going to make a list. How could I get negative 24? I'm going to go 1 times negative 24, or 2 times negative 12, or 3 times negative 8, or 4 times negative 6. 5 doesn't work. Once I'm at 6, it's already back to 6 times 4, 4 times 6. So anyways, which of these pair of numbers combines together to give us the middle value, negative 10? If you combine negative 6 plus 4, that'll give us a negative 1. It's like negative 2. It's like having $4 and owing $6. You're still going to owe $2. That's not a negative 2. If I combine negative 8 plus 3, that gives me a negative 5. That's not a negative 5. It's a negative 10. If I combine negative 12 plus 2, that'll give me a negative 10. So this is the correct pair of numbers that I want. Here we go. So I'm going to plug in exactly those numbers, a positive 2 and a negative 12. And ladies and gentlemen, we have completely factored. We pulled out the GCF, and then we attempted to continue factoring, and we successfully factored that blue quadratic trinomial. Now, this is not always going to happen. What do I mean by that? Let's take a look at number 22. And it looks like it has a GCF of what? What could I pull out?
2.
A 2. Bless you. So we're going to pull out that 2. And when I pull out that 2, what do I have left over on the inside? I have 2 times what gets me back to 2x squared? X squared. Then the next term, 2 times what gets me back to 28x? 14x plus 14x. And last but not least, 2 times what gets me back to 64? What's half of 64? 32. All right, so now we look at the inside blue quadratic trinomial, and the a value is no longer 2, it's now 1. And maybe, just maybe, I could continue factoring, putting an x here and an x there, thinking of the multiples of 32. What times what is 32? That C value, that if I combine together is the B value, 14. I am going to make a list. How could I get 32? That would be 1 times 32, or 2 times 16, or 3 times, nope, how about 4 times 8? Yep. 5 doesn't work, 6 doesn't work, 7 doesn't work. 8 times 4, I already have that as 4 times 8. So those are the 3 possible ways of multiplying numbers together to get the answer 32. Now, if I combine 32 plus 1, I'll get 33, and that is not a 33. Don't go back to the original one. Go back. Oh, you're working on this blue one on the inside. If I add 16 plus 2, that'll give me 18, not 14. Now, some of us might be thinking, well, wait a minute, why not just change that to a negative 2, and then that'll give us 14? You can't do that. If you're going to change a sign, it has to be to both numbers, not just to one of them. All right? So if I add 16 plus 2, that's 18. That's not 18, so this doesn't work. How about 4 plus 8? That's 12. That's not 12. So the bottom line is I cannot continue factoring. This is one of those examples where the only thing you could do is pull out the GCF. So I can't continue doing that. So here's my answer, pulling out the GCF, and the rest is the quadratic trinomial x squared plus 14x plus 32. But you wouldn't know that you couldn't continue unless you actually tried it. So pull out a GCF, try to continue factoring. Most of the time, I'll set it up where you are able to continue factoring, but sometimes that's all you can do. Pull out the 2 and that's it.
You do 21.
Now you may also be able to factor out a GCF like on these binomials. And if we did do that, let's pull out a 2. What would I have left on the inside? I'd have an x squared minus 4. And then once again, like always, if you have a quadratic x squared with the a value of 1 with no number in the front, then maybe you could continue factoring with the x right there and the x right there, thinking what times what is negative 4, that if you combine together is the middle value b, which there is no middle value b, so you want it to eliminate. So you want them to be exact opposite values. Now, even if you were to make a list, how could you get the c value of negative 4? Well, that's either 1 times negative 4 or 2 times negative 2. That's it. Those are the only 2 possible ways of multiplying numbers together to give you negative 4 besides changing signs. Now, when you combine them, when you say 1 plus negative 4, that's a negative 3. There's obviously no middle term that has a negative 3x. But when you combine 2 and negative 2, that ends up being 0. That eliminates. So that's what we want. We want this pair of numbers right here, the 2 and the negative 2, positive 2, negative 2. All you got to do is bring out that outside GCF, bring it down, and you're done. There's your completely factored form. 2 parentheses x plus 2, x minus 2. So obviously, I'm only doing a couple of these, and you got the rest of this period to do the rest of this front side of the worksheet, because the only way you're going to get really good at this is practicing, right? Now, there is one question, I believe, on the test that's factoring by grouping, and I gave you 3 practice problems right here. Which one would you like to see right now? 29. All right, so if we take a look at 29, again, factoring by grouping, it tells you what to do. You're going to make 2 groups. So first, just rewrite it. 6x squared plus 15xy. Leave a blank spot, and then minus 2x minus 5y. Okay? And then right below your first group, put some parentheses. So we're going to put some parentheses right here, and then think about what's in common in the 2 terms of this first group. What could I pull out? Well, the 6 and the 15 have the multiple of 3, but I also have some x's in both terms, so I could pull out a 3 and an x. So everybody put a 3x out here as the GCF of the first group. And what would be left over, think about this, 3x times what would get us back to 6x squared? 2x, perfect. All right, and then 3x times what would get us back to a 15x with a y? 5y, so plus 5y, okay? Now let's do the same for the second group. Look at the second group, put some parentheses right below it, and then think, well, is there any numbers that I could pull out? No, but then again, look, they're both negative, and I want them to be positive on the inside. So what could I pull out to make them positive? A negative sign, right? So I could pull out a negative, especially a negative 1. Negative 1. Because I really can't pull out any x's from both terms or y's from both terms or even any numbers from both terms like 2 and 5 that have nothing in common. But if I do pull out a negative 1, at the very least, that binomial, that second group, will change to a positive 2x and a positive 5y. And that is a really good thing because look at the first group. The common binomial there is 2x plus 5. Common binomial here is 2x plus 5, which means I could actually pull out that common binomial. So the next step on factoring by grouping is to make some exaggerated parentheses and pull out that common binomial, the 2x plus 5y, pull that out over here, 2x plus 5y. And then what's left over on the inside of the big parentheses, the 3x comes down and the minus 1 comes down. So we have a 3x that comes down and a minus 1 that comes down. And that's your factored form answer. Of course, just write it with the correct size parentheses, 2x plus 5y times 3x minus 1. And of course, if you are not confident of your answer or of your work, you could always distribute, like 2x times 3x, it'll give you 6x squared. 2x times negative 1 is a negative 2x, which is right there. 5y times 3x, that's 15xy. There it is, 15xy. 5y times negative 1, that's negative 5y. There it is. So it really does check out. It really does work. So we did do this correctly. You have 2 more of those to practice with, and you have a whole front side of this worksheet to practice. Tomorrow we'll continue with factoring quadratic trinomials that don't have an a value of 1. That's that multi-step process. Step 1 is multiply a times c. Step 2 is to make a list of the multiples of that answer. But we're going to hold off on that till tomorrow. Right now, I just want you to focus in on the front side of the worksheet, all right? And hopefully, after this worksheet, it's 46 questions. That's a lot of practice. Once you guys do this worksheet, you have enough practice to get a better grade the day after tomorrow when we retake this test.